Okay, so we're going to look at these couple formulas real quick. We have the recursive, and all that is it says an is equal to the an minus 1 plus 2d. All this is saying is that if you know the term before it, and you know the common difference for an arithmetic sequence, you can add the common difference to the term before it, and that will give you the next term, an. And so it's not, I mean, this formula is useful sometimes. It won't always be the case that it's helpful because, for instance, if I ask you what the 85th term is and you don't know what the 84th term is, you'd have to figure out what 84 is, then add 85, add the d to it to get 85. But that's kind of impractical because there's a different formula that we use for that. The other general formula is an is equal to a1 plus n minus 1 times d. Remember, this is the formula where I wrote n times d, but it's n minus 1 times d. You have to account for the first term. And then we have the Sn, the sum of the numbers, is n over 2, a1 plus an. We talked about this one. I think I wrote it a little bit differently, though. I think when I wrote it last time, I wrote n, a1 plus an over 2. Same formula, everything. And then we have a summation from 25. We have I equals 1, 5i minus 9. Now, remember in the last video what I did was I went and wrote this out. Well, you don't want to write 5 times 1 minus 9 plus 5 times 2 minus 9 and keep going, because you're going to have to do that 25 times. So, you know, that's a lot of work. So we can use this formula here. That requires us to have a1 and an. So a1 is easy. 5 times 1 minus 9 is going to be 4 minus 9. Oops, sorry. 5 minus 9, which is negative 4. Then we need to know what 25 is. So 5 times 25 is 125 minus 9, which I think, is that minus 4? I better make sure. I don't want to mess this up. 5 minus 9. Yeah, and then 125 minus 9. 16, yeah. Okay. So we've got minus 4, oops, and 116. So we've got, this is an, well, this is technically a25, but that's the n because it's the biggest one. And this is a1. So if we do n is 25, so s25 is equal to 25 times a1 negative 4 plus 116 over 2, which is 25 times 112 over 2, which is 25 times 62, not 60, 56, 25, let's see. So we got 25 times 112 divided by 2, 1400. So the sum here is 1400, which is right. It should be, yeah, that should be 56 times 25. So we've got our sum, so that would be how you'd calculate that one. Obviously, that is way faster than writing out each of these and then adding them individually. Then we have some other formulas. For instance, we'll do a couple of these. If we do 1, a1 is equal to 200. D is equal to 20. They want the first 6 terms, so they want a2. Well, a2, if a1 is 200, and d is 20, then a2 is 220. Just add 20 to it. We're using the recursive formula. That's useful for this one. That makes this one quick. A3, 240. Just keep adding 20 to each one. A4, 260. A5, 280. And A6, 300. So that went pretty quick. So those are the first 6 terms. Let's keep looking. We're looking at I think that's that. Let's do 15 now. 15 is going to be A1 is 13 and D is 4. So they want you to find A6. So A6, we could add 4 multiple times, or we can just do A6 is equal to A1, 13. I'm going to need more room. Oh. I think I need to restart my Surface Pro. 13 plus n minus 1, 6 minus 1 times 4. 13 plus 5 times 4. 13 plus 20. 33. So that would be your solution for that one. And so on and so forth, guys. You just use the formulas and you get the answers. It's not too difficult. I hope that you guys find this kind of easy. It shouldn't be that difficult. Some of them might be a little bit more challenging, but you just have to kind of think outside the box and use a little bit of algebra. I hope that helps, guys. I'll be posting more videos soon.